Today I'm going to introduce you to GNU PLOT. GNU PLOT is a great application for making attractive publication quality plots. It is free open source software, you can't beat that, and it's available at gnuplot.org. So let's begin. First things first, GNU PLOT is one uses GNU PLOT with ASCII files. Suppose I have data stored in ASCII files. In Brownian.dat, I have two-column ASCII data. We imagine the first column to be the x-axis and the second column to be the y-axis. And let's also work with normal.dat. Again, that's also two-column data, with the first column corresponding to the x-axis and the second column corresponding to the y-axis. So let me show you what's in Brownian.dat. I'll just peek at the head of it. Here it is. Here's our first column, here's our second column, and here is a peek at normal.dat. Again, this is our first column and then our second column. Alright, so let's fire up GNU PLOT by typing GNU PLOT from the command line and hitting enter. It doesn't require any arguments, just GNU PLOT. And here we are. So when you open GNU PLOT, depending on your environment, your terminal type is going to be, the default terminal type will be set to perhaps Aqua, perhaps WXT. On some older versions I've seen, it's even set to X11. I strongly recommend that when you start GNU PLOT, the first thing you do is set the terminal type to WXT Enhanced. And it's this terminal that, in my experience, gives you the greatest degree of flexibility and functionality. So here we go. Let's plot the data found in Brownian.dat, and let's plot the data found in normal.dat. And here it is. Notice that I'm plotting two different files, Brownian.dat and normal.dat, and GNU PLOT is going to select different colors for each. So that's kind of nice, although I have to tell you the choice of green does not show up very well on projectors when you're doing a PowerPoint or using making a presentation with a projector. So first things first, let me show you how to change the line color. Suppose you want black. Black and white gives you great contrast. In order to change the line color, I type LC for line color, RGB, and then in quotes, black. And now my normal.dat data is plotted in black, while my Brownian.dat data is still plotted in red. Other colors are possible. I could do blue, I could do green, I could do gray. I think I have to use the American spelling. There it is. Let me go back to black. And let me also change the line color for Brownian.dat. I'll change that to black as well. There we go. Let me set a title. Set title example plot. That seems good enough to illustrate the point. I'll plot Brownian.dat and normal.dat again, and look, I have a title now, example plot. Now let me give labels to my y-axis and my x-axis. Set y label. This is the y label. And for argument's sake, let's use Greek characters for my x label, just to illustrate how to use Greek characters. So in order to get a Greek character, I do / open curly bracket, symbol with a capital S, and let's see, maybe I want alpha, beta, let's see what else, maybe throw a tau in there for fun. Close my curly bracket, and I close quote. And now when I make the graph again, oops, something went wrong here. Interesting. There we go, my bad. I transposed the curly bracket in the forward slash. But all's well now. So here's my plot: title, Y label, X label. And notice these guys out here. This is actually telling me the name of the ASCII file from which the data came. Brownian.dat, normal.dat, and also the symbol type that's associated with each data file. Now that's nice, but that's generally not what we want to appear on a plot that we're going to show to others. So let me, first of all, I can show you how to get rid of the key if you just don't like it. Type unset key, hit enter, and then plot again, and the key goes away. If you want the key to return, just type set key, and we can change the text in the keys by doing the following. So for normal.dat, I have line color RGB black, and I'm going to set the title for normal.dat. Maybe I'll type normal. And for Brownian, I'll set the key to be, well, Brownian. And now our key is set to Brownian plus using the plus symbol, and normal using the X symbol. But you'll notice that my data is somewhat obscuring my keys, so in order to get my data off of the keys, instead of going from -10 to 70, perhaps I'll go from -10 to 90. And in that case, you'll see the data will come off the keys. So I set the X and Y range like this, using hard brackets. The low range and the high range are going to be separated by a semicolon. X comes first, then comes Y, and since I'm only going to be changing the upper Y limit, I'll just put a 90 in there, and I'll plot it again, and there we go. I go from -10 to 90. Now while we're at it, let's notice that I have a large ugly gap on the right side of my graph. So I happen to know that my data run out at 1024. In other words, I have 1024 rows in my data. So let me put 1024 here, hit enter, and look, my data now fills the graph from left to right. Very nice. I can add a grid if I prefer by typing set grid, plot the data again, and now I have a grid. So this is my crude primitive plot. There's really not a whole lot to it, but let me show you how to save it now to an encapsulated postscript. We can use the encapsulated postscript in a LaTeX file. So here we go. Set terminal type, or I can just abbreviate terminal with term. Set term postscript EPS enhanced, and I want to set the font type to be Helvetica, and I want the font size to be 24. So I hit return, and the terminal parameters are spat back out at me, so I can see what my terminal parameters are. By the way, if at any time you want to tell GNU PLOT to show you what those terminal parameters are, just type show term or terminal. Now that I have my terminal type set to encapsulated postscript enhanced, I'm going to set my output file name to be, well, how about example.eps? That seems as good a name as any. Example.eps, and now I type replot, I hit enter, and I claim that my plot has been sent to an encapsulated postscript named example.eps. So let's get out of GNU PLOT and take a look. Aha, there it is, example.eps. Now let's open that up and see what it looks like. Here it is, here's my plot. Let me make this a little bit bigger. I have my title, my key for the first data, key for the second data, my Y label, my X label, using Greek characters, by the way. Oh, and also notice this: as I zoom in, EPS is a vector graphic. So I can zoom in arbitrarily close and the lines are still going to stay sharp and crisp, which is very nice. So this has been my introduction to GNU PLOT. It was short and sweet, just covered the absolute basics, and I hope you find it helpful.